We're going to take our warm-up a step further. So instead of like 5 times something, we got 4x and 8. We're going to try to get there from 4 times x plus 2. So you'll see in this box, this one's horizontal instead of vertical. We've got a 4 by an x plus 2. So 4 times the x gives me 4x, and the 4 times the 2 gives me 8. I want you to do the same thing with n times 2n plus 5 with your partners. Let's go. Raymer said a good point. He said, isn't it showing us the answer already? You're justifying it with the area model instead of just finding it right now, right? So we're justifying. So let's do that. What's 2n times n?
2n times n is 2n squared.
And what's n times 5?
5n.
So this is 2n squared plus 5n. And what this is saying is the area model proves that this distributive property of n times 2n, n times 5 is 2n squared plus 5n. Everybody good? Okay. So we don't have to draw the area model every time. You can if you choose to. It's a great problem solving. But you can't just do the distribution where you distribute like this. Okay? So we'll practice that on A. You and your group are going to run through B, C, and D. So 6 times 1/3 n.
6 thirds n.
Which is 2n. Yep. And then plus 6 times 2? 12. So this one's just showing you don't have to do the area model. You could choose to if you wanted to. B, C, and D with your group. All right. Let's start rolling through these. Help me out. What's P times 4P? 4P squared. And what's 9 times P?
9P.
All right. Next one. What's 5R times R?
5r squared.
And what's 5R times 3/5?
3r.
That one's quadratic. That one's quadratic. Last one. What's 1/2 times W times W?
0.5 W squared.
Yeah, half W squared. And what's 7 times W?
7w.
A point I want to make that you're going to want to do and want to mess up. 5 and R, are they magically attached?
No.
What does 5R mean?
5 of R.
Yeah.
5 times R, right? They're not magically attached. So when I do 5 times R, that's why I get the R squared. R times R is R squared. I can't do anything with the 5 because the 5 is just 5. It depends what R is, right? Okay, just know they're not magically attached. So we're going to take this a step further. We're going to use this on 2 things times 2 things now. All right. Somebody might say a binomial times a binomial if you want to get fancy. Two numbers times 2 numbers. So what do you guys notice is different about my diagram now? There's 4 boxes, right? We had two boxes or 2 rectangles before. Now we have 4. The reason is we had 2 because it was a 2x1 situation. This is a 2x2 situation. Okay? So really what it's making us do is multiply everything by everything. Everything by everything. Okay? So for this top left box, what's x times x? 3 times x.
3x.
X times 1.
1x.
X. 3 times 1.
3.
Did I say 3 times 1 instead of x times 1 there? Anyway, these are the areas of all these boxes. We follow? Base times height for every box. And then I'm going to rewrite my expression with my like terms simplified. Here's my 4x right here. 3x and x is 4x. I add areas up to make a composite area, correct? Okay. Just quick refresher. Quadratic term, linear term, constant term. Just keep that in mind. This is what makes it quadratic, though. Okay, you're going to, for A, B, C, and D, you're going to draw diagrams like I did up top to get answers. The one thing you need to do for A, that you're even going to mess up later today probably, you need to expand it to look like this to be successful. Because the number one wrong answer for this is this. And people write it all year, and they shouldn't. That's the wrong answer. Can you see why people might say that's the answer? Okay, but it's not the answer. So make sure if you get something squared, a binomial like that, x plus 5 squared, write it out as x plus 5, x plus 5. You're going to be more successful. So I want boxes and answers for A, B, C, and D with your group. So for A, I need a 2x2, an x plus 5, and an x plus 5. Then I'm just going to find the area of each individual box. So the top left, x times x, x squared. Top right, 5 times x, 5x. Bottom left, x times 5, 5x. Bottom right, 5 times 5. And with all those areas combined, that's the whole thing. So I have x squared plus 10x plus 25.
Oh, I didn't do that.
But that's what it is, Bob. That's what I'm showing you. Okay.
How do you get the 10x though?
5x and 5x is 10x.
Where do you see that in the
But how do you
equation?
get the number answer?
How do I get the number answer?
The number
I
answer from the area.
add up all the little squares to get the whole square. That's how.
Well, I'm just
Yeah,
asking
but
where you
how do
see
you
it
know
in
what
the
x is
equation.
to get the answer?
I don't know what x is. It's not set equal to anything right now. This is just an equivalent expression. This is the answer.
The answer is the equivalent.
The answer is the equivalent expression. They're in different forms. We haven't learned the name for the forms yet. That will be coming, but yeah, Finn.
Does the order matter?
Kind of. You either want to go like, remember the cannonball? We started where it started, how fast it's going, and then gravity. Or you want to go second power, first power, no power. You don't want a random. It's usually lowest to highest or highest to lowest with like, it's called degrees of the term. So this is a second degree term, first degree term, 0 degree term. So this is the standard. Now this is called standard form because we have three things here, right? We have the quadratic, the linear, and the constant. Do you guys see how that 10x doesn't pop if you look at this right here? That's why I said you're going to want to write this, and this is wrong. The 10x comes from x times 5 and x times 5, which is there. You have to distribute everything to everything. Okay, let's look at B. B is a little different because I have a 2x and I have an x plus 4. So this isn't a 2 by 2 box. This is a 2 by 1 box. What's 2x times x?
2x squared.
And 2x times 4? 8x. So simplified here, 2x squared plus 8x. Go try to fix up C and D. Okay, so let's check out C and D. So C is going to be a what by what for a diagram?
2x plus 1 by x.
How many boxes do I need?
4.
4, 2 by 2. So I have a 2x and a 1. I have an x and a 3. So top left, 2x times x.
2x squared.
2x squared. 1 times x is x. 2x times 3, 6x. And 3 times 1, 3. So my simplified expression then, 2x squared plus 7x plus 3. And this expression is equivalent to this expression. So once we get in more context and deeper in the unit, you're going to see you want different forms to do different things with a quadratic. Like this one's really good for y-intercept. This one's really good for finding zeros. You don't know that yet. We haven't done it, but that's why we need the flexibility. All right, last one, D. My box is going to be what by what?
X plus m by x.
How many by how many?
4.
2 by 2. So I have an x and an m, and an x and an n. I'm multiplying everything by everything. It's kind of like the lattice method of multiplication. You guys remember that? When you did like 2 by 2 and 2 by 3, you made that lattice. Same thing. X times x.
X squared.
M times x.
XM.
I'm going to go mx, but x times n.
X.
And m times n. I can't combine any of these. None of these are like terms. So it kind of doesn't matter what order. All those terms just need to be there. All right? This total area is all of it added up. We got to multiply everything by everything. That is the distributive property. Okay, I'm going to show you how to do it without a diagram now. But it's the same exact thing as with the diagram. You just don't draw stuff. So let's look at x plus 2 times x plus 6. To do it without a diagram, I'm going to take x and multiply it by both things. I'm using those little, what do you want to call those?
Belly buttons.
Those are not belly buttons, they're just like lines.
Those are rainbows.
Kind of like arrows. Anyway, those arcs. I'm going to use those arcs to show what I'm multiplying. I'm going to do x times x first.
X squared.
X squared. Then I'm going to do x times 6.
6x.
6x.
And then I need to multiply everything by 2. What 2 times x is?
2x.
2x. And then 2 times 6?
12.
I'm going to combine like terms.
I get it, man.
It's the same thing as the box diagram.
The boxes just made it more confusing.
No, it's based on an area model, which you should know. It's the visual representation. It is not different. It's the same. Okay, so you're going to try out B, and I'm actually going to give you letter C to try out. B and C, let's go. So looking at B, I'm going to erase some stuff here just to have a little more room to write. I'm going to distribute my x first. So 2x times x is 2x squared.
How does that work? 2x times 2x.
X times 2 times x, I can multiply in any order. It's 2x squared. 2 and x aren't magically connected. It just means 2 times x. Okay. So 2 times x, 2x times x is 2x squared. Then I've got 10 times x, which is 10x. I still need to multiply both things by my 5 term. 5 times 2x is 10x. And 5 times 10 is 50.
Yes.
Now I need to combine my like terms. 2x squared, 20x, and 50. The value of this expression, important to know, samesies. They're the same value. They're different formats. And you'll see in a little while, different formats have different strengths. We want the flexibility to go back and forth between the formats, okay? Last one, C, most commonly wrong even on the quiz when you take the quiz next week. I suggest doing this every time. Expanding.
That's what I did.
X minus 2 squared is x minus 2 times x minus 2, correct?
Yeah.
Okay, so I'm going to distribute my x first. X times x, x squared. X times negative 2, negative 2x. I now need to distribute my negative 2. Negative 2 times x,
Negative 2.
have 2x. Negative 2 times negative 2,
Plus 4.
plus 4. So the result is x squared minus 4x plus 4.
When's our test?
Monday or Tuesday. Okay,
Monday, Tuesday.
again, not a different value, different form. Different forms are going to give us different information for contexts. Make sure when we combine our like terms and we're adding, a negative 2 and a negative 2 makes a negative 4. Okay, you're going to practice this with your lesson summary, y'all. Here it is. Get after it.